The barrier to creating software has hit zero. Today, you can type a few sentences into an AI interface and watch a fully functioning application spin up in seconds. But prompt-generated code often hits a wall in the real world. One security audit of a prototype built entirely on Vibes returned over 160 pages of vulnerabilities, from SQL injections to broken authentication, because the AI lacked a structural framework to follow. If you are trying to figure out how to actually use AI for development right now, you are likely navigating three overlapping terms: AI-assisted coding, vibe coding, and agentic engineering. Let's separate them. AI-assisted coding is the baseline. This is a developer writing code using AI as a high-speed autocomplete typist to fill in the functional blocks. Vibe coding is different. This is when a non-developer builds an application using only unstructured natural language prompts, focusing entirely on the desired outcome instead of the syntax. Then there is agentic engineering. This is when AI operates autonomously, designing, executing, and iterating on software based on a strict set of system rules. Generating code is the easy part. Your actual challenge is choosing the right engineering paradigm for your specific skill level and end goal. When you rely solely on vibe coding, you are operating in single-player mode. You give the AI a prompt, it gives you code. But the moment you close that chat window, the AI loses its context. It forgets your security protocols and your architecture. This matrix maps the contrast. Left, vibe coding is stateless, relying on your intuition. Right, agentic engineering is a stateful, rule-based system. Notice the right side. Because it is stateful, it retains system memory, tools, and rules across multiple sessions. It never forgets your infrastructure. Making this shift from single-player prompts to multiplayer orchestration dictates whether your software can actually scale or if it will collapse under its own technical debt. Let's look closely at vibe coding. Operationally, your input is nothing more than unstructured natural language typed into a stateless chat interface. The outcome is a massive gain in speed. You can get a minimum viable product running in minutes, allowing non-technical users to build software that previously required a team of engineers. But there is a trade-off, and it goes back to context amnesia. Because the chat interface forgets your overarching architectural rules, the AI defaults to whatever is fastest. That leads to high technical debt and insecure defaults, like exposed keys or bad database queries. If you try to take these vibe coded applications and scale them up with real users and real data, they frequently break apart because they lack a persistent logic layer. Vibe coding is an excellent tool for testing ideas rapidly, but treating it as a production-ready engineering tool is a liability. If you aren't a developer but want to build robust systems, your input changes. Instead of typing into a chatbot, you assemble no-code agents on platforms like Tascade or Flowise to handle context, planning, execution, and learning. The outcome here is persistent multi-agent orchestration. You are building workflows where specialized AI agents complete specific tasks and hand them off to one another. For example, you can set up a pipeline where a research agent scrapes data, hands its findings to a writing agent to draft a report, which is then passed to an editing agent for review. The trade-off for this setup is that you are strictly limited to the pre-built external integrations the platform provides. Because you lack granular control over the execution environment, dealing with highly specific edge cases or custom internal APIs becomes a significant challenge. No-code agentic engineering provides system reliability for business automation. You trade granular control for accessibility, but you get a system that works consistently. For enterprise developers, the input is structured. Instead of prompts, you codify constraints using .agents.md files, injecting rules directly into the AI core. When a prompt enters, the core checks it against your rules. If it violates security, the system flashes red and rejects it. This enables shift-left security. You are forcing the AI to default to your specific architectural standards before a single line of code is even written. The trade-off is time. It requires significant upfront architectural setup and planning to build those constraints. This rigorous environment removes the freestyle spontaneity you get with vibe coding. You aren't hacking things together on the fly anymore. For enterprises, vibe coding is risky. Your job isn't writing code, it's engineering the AI's constraints. To avoid AI technical debt, match your project phase to the correct AI paradigm. Start with one question: can you write code? Following the No branch, if your goal is app generation, use vibe coding. For business automation, route to no-code agentic platforms. If you are a career transitioner, treat vibe coding as a gateway to learn the concepts, but focus your energy on no-code agentic workflows to build a true career moat. Now watch the Yes branch for developers. If you are working on a weekend hackathon, route to vibe coding. But if you are building for production, you must use context primitives. Enterprise developers must take the production path. Trying to shortcut this with vibe coding invites security vulnerabilities into your codebase. Regardless of which tool you choose, the shift is the same. You are moving from being a prompter to being an architect. As this animation shows, a chaotic input must be captured and harnessed by a strict framework to generate a steady, usable result. The specific AI model you choose matters far less than the engineered harness built around it.